I hope everyone's having a great day. I'm Mr. Ish. Thank you for joining me. We're looking very briefly at this concept of taking a derivative and working backwards to get to your original function. If you're provided a derivative and that derivative is expressed in some sort of a functional format, and then you're also given additional information with regards to your original function, how can you find what that original function was? Here we know that the derivative is t root t. We also know 1 plugged into the original function gives you a value of 2 in terms of the output. Think to the fundamental theorem of calculus or the inverse relationship between derivatives and integral. We have a t root t. That's the derivative. T root t is no different than t to the power of 3 over 2. If you were to take the integral of this, you would end up back to some original function, and that's what we're trying to do, and that's the procedure which would very well help you. You do t 3 over 2 plus 1 over 3 over 2 plus 1. You'll have t to the 5 over 2 over 5 over 2, and you'll have 2 over 5 t to the 5 over 2 plus c. This right here would equal your original function. If you are to look at this and then you have this information, you can very well plug in, find c and get to your original function. If you look at this, you have 2 over 5, and we know when 1 is plugged into this, 1 to the power of 5 over 2 plus c, we have an output value of 2. This right here is 2 over 5. 2 over 5 plus c is equal to 2. C is equal to 2 minus 2 over 5, which would be 8 over 5. The original function must be nothing more than just this right here. 2 over 5 t to the 5 over 2 plus 8 over 5. And that right there was your original function. You can express this all under a single denominator if you want, but I want. And that right there is good. And this is how you would go about doing something like this. Let's look at this question right here. You have what happens to be a second order derivative which has the function value of 6t plus sine t. You have to find what the original function was. Again, no different than you taking that derivative and working backwards. It's kind of like you taking an antiderivative and you're doing its derivative to go back to the integrand, which was originally the function that you're looking for. You can undo everything here in terms of the derivative with the integral procedure and start working backwards. If you look at the second order derivative and you did its integral procedure once, you'd be at the first order derivative. Then you do the integral procedure once more, you'll end up right at your original function. And that's the procedure you want to take. You'll do 6t plus sine t and you will do its integral procedure. When you do this, 6t is, remember, polynomial t, 1 plus 1 over 1 plus 1, you'll get a 6t squared over 2, and for sine t, you'll get a minus cosine t. But do not forget your constant of integration. It has to come through, because when you're doing an integral and you have an indefinite, you must bring in that. Simplify this. You will get a 3t squared minus cosine t plus c. What does this represent? This represents the first order derivative now with respect to t. You must do this integral once more to get to this, the zero order. And you can do that. You do 3t squared minus cosine t plus c. Don't forget to include this into your integral. It has to go through. When you do this, it's not hard. You again do the regular integration procedure. 3t squared will become 3t cubed over 3 minus cosine t will become a minus sine t. C now with respect to the t variable will become a ct, and now as a result of this going through an indefinite integral procedure, you must bring a new constant of integration. Simplify this to get to your function that you're looking at, your zero order function with regards to t. It'll be t cubed minus sine t plus ct plus d, and there it is. And this is how you're going to approach these type of questions. These type of questions come in the chapter in the calculus book which are under the topic of antiderivatives. You're using the procedure of doing an integral on a derivative to go back. You're essentially doing, rather than a derivative on an antiderivative, you're doing an integral on a derivative to go back to the original function. And this is how you would undo the effect of higher order derivatives to get back to your original zero order derivative. Thank you for watching. Have a nice day.